Well, now we'll talk about linear independence of solutions. And if you recall from linear algebra what linear independence means, and I will write linear independence, what we know is that if we have some sort of set of functions, so y1, y2, and on up to y sub k, then if we find all linear combinations, so c1 times y1, and then plus, that'll be c2 times y2 plus on up to c sub k times y sub k, then this does not equal 0 where, and then when c1, c2, on up to ck do not equal 0. In other words, none of these solutions can be written as a constant multiple of another, or none of these solutions can be written as a linear combination of the others. So as an example, what we can show is if we have two functions, y1 is equal to e to the x, and if y sub 2 is equal to e to the 2x, then what we could write is we could say, okay, well, we have c1 times e to the x, which is y1, plus c2 e to the 2x, and this is equal to 0. And what we want to show is that this is, in fact, not equal to 0 when c1 and c2 do not equal 0. So what we can do is we can subtract the right term, so we get this on the other side, and I'm not going to worry about the negative because it's just a constant and it's irrelevant here. So now we can divide both sides by c2 and e to the x, and we get c1 over c2 is not equal to e to the x, and this just reduces to some constant which we will call c, and c is not equal to c e to the x. Now if c does not equal 0, right, then we would have something that would be like, okay, we could say this is equal to 1 then this is not equal to e to the x. And this is true because obviously e to the x is a function of x, which changes as we change our input of x. And on the left-hand side, we just have a constant. And obviously these are not equal to each other. So those two functions, e to the x, and e to the 2x would be linearly independent. In the next video, we're going to show how linear independence will help us to find the general solution of a homogeneous differential equation. If you have any questions, please leave a comment below. I'll be sure to respond. Please subscribe to help the channel to grow and so I can continue to post future content. And I will see you in the next video.